I'd like to bring up Mofizur Rahman, talking about managing Kubernetes deployment with Istio. So Mofi is a developer advocate at IBM, and he's a big focus on container orchestration. He's a big fan of Golang, and he loves collecting stickers. So if you got a few rare ones, definitely meet up with him after those and trade some stickers. So give it up for Mofi.
Hello, everyone. So I don't know after the talk starts if you're going to leave or not, so I'm going to quickly take a picture to prove you are here. All right, so that's out of the way. So the title of the talk today is Managing Kubernetes Deployment with Istio. But before I get started, let's get a level set of this room, what we have in this room at this moment. So how many of you are dealing with microservices? All right, cool. I wanted to see like all the hands up, but that's okay. Next up is containers in production. Docker, some version of containers, a little bit less, that's fine, that's understandable. Finally, Kubernetes, either using already or in the platform, pipeline. All right, awesome. So we're talking about something that abstracts a little bit more, even more on top of Kubernetes, so it helps if we all on the same page. So we're going to just quickly go over the kind of the levels that everyone who didn't raise their hands up, so get everyone on the same page. So what we're going to learn today? We're going to learn what Istio is. I said we're going to learn about Istio deployment, but we want to also know what Istio is good for in general. Understand app deployment in the Kubernetes world, how this kind of current stage is just by default Kubernetes. And finally, see why we might need Istio, and what does Istio give that's better than Kubernetes already gives us. That's my picture. I think it's a much better looking version of me. So if you don't like looking at this, you can just look at that. So my name is Mofi. I'm a developer advocate at IBM. I mostly work on containers, microservices, Kubernetes stuff, open source. I mostly write with Golang. And I also, as he said, collect stickers. So if you have some rare ones, please do see me after. And you can find me on Twitter at MofiCodes. Actually, you can find me anywhere in the internet with almost at MofiCodes. So do find me if you need to. So monolithic application, love it or hate it, that was the state of application building as we know it, right? So you have your user, your application, some sort of data source the application needs. But in reality, most of the cases, that application wasn't just this one thing. It was 10 different things piled into one big giant thing with some data source. That was not good for the industry because deployment was difficult, testing was difficult, scaling was difficult. So solution, microservices. Really a solution? I don't know, but it was there. Microservices is the idea that you have this application broken down into services, each of them individually testable, deployable, you can scale it up. The promise was everything, but did it really fulfill all of that? We'll ask that later. But microservices was there, that was the promise. So in a microservice world, you still have your user, your application is broken down into individual services, you still have some sort of data source. In many ways, microservice was basically a distributed monolith, right? So your application, what it needs to do, still has to do those things, but instead of being one giant application, you have then 10 smaller applications, but still has to work together somehow. So distributed monolith it is. And before, people used to complain that, oh, Friday, 5 o'clock deployment, scary, right? But now you have these 10 different services. Each of them has to be deployed, scaled accordingly. So now you have that 5 o'clock. It's every day, every hour. So any developer tell you this before? It works on my machine. So I think they literally invented Docker to solve that issue. So Docker is where you have an application, you take all the dependency, package it up in this nice thing. As long as you have a Docker container runtime somewhere, you can run that application anywhere. And application and host are decoupled, so it's easier to then scale and test. If your developer can package it in Docker, you can test it in any environment that supports Docker. But containers and Docker, whichever you use, doesn't really matter as long as you can do that abstraction. Your application building still works just fine. So containers in an app, you basically have something called a Docker file. You put everything. This is not important. This is not any special application or anything. But this is the kind of file you do. You have a Docker image. We're all happy. So we abstract away the host. We no longer want to control our VMs. We have our Docker images running all over the place. So we want to say our application needs 3 copies. Fine. Does the Docker run? 3 copies running. Something goes wrong, right? At this point, everybody will tell you, don't exec into Docker. You shouldn't look into the Docker image. If something goes wrong, spin up more copies because it's cheap. Okay. Something else goes down. You still don't want to look into it because again, you have better things to do, you know. You spin up more, catches fire, spin up more. At this point, everything's on fire. So Docker wasn't enough. If people understood it pretty quick, Docker by itself wasn't enough. So we started thinking about container orchestration. We had a long-fought battle between Docker Swarm, Mesosphere, Kubernetes. Finally, probably Kubernetes won that battle, at least for now. So what is Kubernetes? It just provides abstraction from an infrastructure to your containers. Kubernetes, it gives infrastructure resource, it kind of goes away. What's your node, what's your master? From a point of view of an operator, it kind of is not there anymore. You have some nice sets of APIs that you call to get resources to be running on Kubernetes. You have a built-in scheduler that schedules your pods to be run somewhere. You have a load balancer on top that directs traffic to different places. Things were looking good. So you Kubernetize an app, and you heard it here first, folks. That's a new word I'm trying to coin, Kubernetize. So if it catches on, it's my credit. But so you basically have your application. You have things called deployment services. Again, implementation details. That's how Kubernetes does things. Doesn't really matter what they are, but somehow Kubernetes gets your application from code to deploying on Kubernetes. So let's take a look back again, what we had in our monolithic world. You had a user, application, some data storage. And then we move to this. We have a cluster-wise load balancer. You have your different services running. Some of them may need some database. Some of them may need some message queue, what have you. But as you keep building your application, it goes bigger. And some services sometimes need other services. They need other services. So your dependency kind of looks like a big graph from top down. So let's say day 2, you want to say, my application is ready. That's the microservice I have. I'm going to spin up a copy of it. Traffic coming in. Business is booming. Very good. A lot of people coming into your business. All of a sudden, you need more copies of it. That's fine. Kubernetes can do that. But something catches fire again. But you remember Docker, you're not supposed to look into it, right? Don't look into the Docker image. Kubernetes kind of has the same problem. You shouldn't look under the hood what's happening at the individual container level. So what you do basically, let Kubernetes kill that particular pod or deployment, spin up more copies, then something else catches fire, everything is on fire, we're in the same problem. So at this point, you might be asking, you know what, I use the greatest and the latest, Kubernetes is the best thing we have so far. You know, this might be it, right? This is fine. I mean, we tried, but sometimes you try really hard and don't succeed. But let's take a step back, right? So this is what many of the industry leaders actually talked about. Kubernetes is a platform for building other platforms. It's a great starting point. It's not the end game. What it says, basically, Kubernetes gives you a lot of these best practices of the industry in like a packaged version that you can start with. But your application need is going to be different than many other people's application need. So you'll have to do some custom things for your application so that your application works the way you want it to work. So let's take a step back again and think about what we mean about deployment. So Kubernetes has some actual primitive called deployment. So don't confuse with deploying an application with deployment in Kubernetes. But I'm talking about what does Kubernetes already give you in terms of deploying an application. So it has a built-in deployment primitive. It supports rolling deployment by default, so you can actually have one version of the app running, you deploy a new version of the app, and Kubernetes can roll into from 1 to 2 by not killing more than one pod or any configuration you want it to do. Also, you can actually have multiple deployment running side by side, and from the service, that is the one people access from outside, you can decide to target both deployment at the same time. And Kubernetes will do something like a round robin to randomly choose which traffic to send where. But when we talk about deployment in production, for many services, we're talking about some advanced deployment strategy like blue-green, canary, A/B testing. They're kind of similar, but not the same. But the idea is you have a version of the app running, you have a new version coming up, you want to slowly and gradually shift traffic from one service to the next. And if you see something going wrong, you want to just quickly go back to the original service without disrupting traffic. So in Kubernetes, by default, traffic routing is round robin. So if you have, like, say, 4 pods running, 4 containers running with your application, load balance will just randomly choose one of the pods to send the traffic to. So basically, if you want to do like a blue-green deployment, and if you have, say, 3 pods of version 1 and 1 of version 2, the best percentage splitting you can do is 75-25, because it's random. And sometimes the reasons you would want probably to have multi-versions services has to do something with features sometimes with compatibility, and sometimes with regional. Let's say you have users that are in a different country, and you want to give them the same application, but a slightly different version. So you want to have multiple versions of the app running at the same time. Also, you can do things like experimental features. Let's say some users sign up for a beta feature from your application, and you want to have them access those features without disrupting other network for other people. Or let's say, who here had to support IE6? Anyone? Yeah, you remember. So that's right. So anyway, so if you had to do something specific to a specific browser, you want to have multiple versions of the application, you might want to have it. So what do we want, right? I mean, we want to do nothing and get a lot of money, but that is beside the point. But we want to have fine-grained control. And we want to be able to roll back if something goes wrong. That's basically all we kind of wish from a deployment point of view. So the left side of the things is what Kubernetes already gives us, right? We want to be easily deploy something and roll back if you need to, also scale up, scale down as we need to. So Kubernetes does pretty well with those. But the right side is where I think Kubernetes needs some extra help. Kubernetes by default doesn't really come with a good way to get metrics out of what's happening in our application, or to get a look, because again, we're not supposed to look under the hood, but Kubernetes doesn't really give us any way to look over the hood either, right? So we have to do some extra work to get observability into our cluster. Also, if something goes wrong, how do we fix it? And how do we know if something is going wrong at the moment? So Kubernetes needs some help with those. So what it sounds like, we want to have traffic management. We want to have observability, security, because again, that's the one thing usually Andrew said is supposed to be in the very bottom, right, in the list. But usually keep it a little bit above the very bottom. And finally, we want to have some policy enforcement. Every company has their own sets of policy they want to enforce. But there is not necessarily a good way to do it without actually changing code, right? Adding a lot of this extra code into your application. So again, these are hard problems, right? Like it's industry. If we all had solved it, we probably would be out of job by now. But these are hard problems. So, I'm not going to say it out loud, but again, this phrase comes to my mind that, these are hard problems. And in the industry, we have been building a lot of different softwares to solve one or some of the problems at a given time. For example, if you wanted to get something like traffic management, you can do something like Nginx. You can have all your configuration to manage traffic going through your application. For tracing, you can use something like OpenTelemetry. For metrics, you can use something like Prometheus. For security and identity, you can use something like Vault. So we started with Docker. Then Docker wasn't enough. We moved to Kubernetes. Now I'm telling you, you need to learn these 4 other things, maybe 7 other coming in next week. So where does it stop? Service mesh. So this is where the talk is supposed to start. So this is going to start now. So service mesh, none of this technology that service mesh comes with are revolutionary technology that changes how we build application per se, but packages a lot of the best practices into this one bundle that we needed and been using with Kubernetes if you're doing Kubernetes in production for a while. It brings in best-in-class solutions, also allows it to do sometimes plug and play. So if you have multiple options for this one solution, you can choose to do one over the other. So what is a service mesh? Service mesh basically allows you to control your service-to-service traffic. That's basically what service mesh is supposed to do. But in reality, what service mesh truly can achieve is give the DevOps team and developers and ops team the ability to know what's happening in the cluster without having to do too much work in terms of instrumentation on the code. And for the most part, the changes that service mesh gives you doesn't really affect the development team. You don't have to know too much about how you're collecting metrics or how you're collecting these logging informations. So service mesh, Istio is one of the service meshes that's out there. There is multiple, many more. Linkerd is one of them. Buoyant is one of them. But Istio is an open source project that started in Google, Lyft, and IBM combination. Then many of the industry leaders actually jumped in and been building this software up as an open source project for a couple of years. It's on version 1.1.7 now, so it's pretty stable as far as like features go, but a lot of work is actively being done on it. So Istio comes with 4 major components. You have Envoy Proxy, you have Mixer, you have Pilot, you have Citadel. Envoy is the project that initially started at Lyft. It's the sidecar proxy that does a lot of the thing Istio can do. So let's look at Istio features, right? Traffic management, it gives you rich routing rules, retries, failovers, and fault injection. Observability, you have metrics, logs, and traces for all traffic, both within your cluster and coming from outside and going outside. You have security, so you have identity-based authentication for ingress, egress, and service-to-service traffic, so you can enable mutual TLS. And you can enable policy that allows you to define who can talk to who at any point in your cluster. So let's say in your Kubernetes you have 2 services. Service A wants to talk to service B. In Kubernetes world, if they're in the same namespace, service A will just say, give me service B. And for the most part, Kubernetes API server can find out what service B is. In the Istio world, what happens is you have this service proxy next to the pod, and any traffic you want to send out from your pod actually goes through the proxy. And the proxy talks to the other proxy, and the other proxy passes the data onto your container. So why this is important is just by using this proxy, you now get access to HTTP, HTTP2, gRPC, TCP communication with or without MTLS if you want to. So how does that work? Magic. But those of us who are lacks belief, it actually uses Envoy. Envoy is the open source project that I talked about. And Envoy gives you all these other things on the right. Dynamic service discovery, load balancing, TLS, circuit breaking, health checking, traffic splitting, all this good stuff just bakes into it. Istio just takes Envoy and wraps it with other functionalities that we're going to look at in a second. So this is what Istio have. The thing we looked at up on top, that's the data plane. And the bottom, we have Pilot, Mixer, and Citadel. Pilot is the one that propagates all the configs to different proxies. Mixer takes in the data coming from the proxies and collects metrics from it and enforces policies on them. And Citadel passes on the TLS certificates on different proxies. So we're going to talk about a demo. It's not the video just yet. We're going to talk about the demo. So the application we're talking about, it's the base application on Istio docs. Since I won't be able to do a live demo, I didn't want to show you something that you won't be able to find yourself. So this is the application. You have a product page, that's the UI. You have a details page. You have a 3 version of the reviews application. And reviews v2 and reviews v3 talks to ratings, and those has the black or red rating stars. So this is our goal. This is what we want to see in the demo. We want to see shifting traffic from v1 of reviews to v3 on a blue-green manner. And finally, we want to do traffic routing based on a specific user. So if you're logged in as this specific user, I want to show you a different version of the app than other users are seeing. So with that, before we start the video, so I'm going to quickly, because the video is very fast, it's going to run for like a minute and a half. So I'm going to say what's going to happen before the video happens. So when the video happens, you can actually follow along. The first demo you're going to see is that I'm going to deploy the applications, and I'm going to just refresh the page a few times. At that time, there is no routing rule. So you're going to see no stars, black stars, and red stars popping up on the screen a few times. And then I'm going to do a 90-10 split. Then I'm going to deploy a version where you don't get any stars. So version 1. Then I'm going to switch to a version where I have 90% traffic going through no stars and 10% traffic going to 1 star, the red stars. Then I'm going to do a 50-50 split. Then finally, I'm going to shift all traffic to the red stars. So that's our blue-green deployment. And the next version is where I deploy a user, a new rule where I say that if the username is Jason, anyone named Jason in the audience by any chance? All right, great. So if you log in, you want to see red stars. And if anyone else logs in, you want to see no stars. So that's the idea. If you could play the video at this point. There you go. So I have like the pods deployed and the deployments running there, and I have the services there. I'm going to shift to the other screen and refresh the page a few times pretty fast. So you're going to see stars switching on the right, black stars, red stars, no stars. Then I'm going to come along and first deploy the V1 version. Now, if I just refresh many times, you're going to only keep on seeing no stars because this V1 version have no stars. Then I'm going to do a 90-10 split. That's what you can see on the name. If I refresh a few times, you saw the red star once or twice. So that's going to happen. Then I'm going to do 80-20 split, by the way. And I'm going to, again, refresh a few times. You're going to see probably the red star show up a couple of times. Then once that happens, I'm going to switch back and do a 50-50 split. That's where you are basically testing your application. You are saying, send half traffic here, half the traffic somewhere else. And if I refresh a few times here, we will see that I will get like red star a couple of times. And finally, I'm happy that my V3 application is working perfectly fine. So I'm to send all my traffic into this version. No matter how many times I refresh now, I should get always red stars. Because at this point, my blue-green deployment is complete. And again, this version of this is we're looking at, so any user that comes in now gets a no star. Now I want to see if the username is Jason, I want to send them to V3. Otherwise, I want to send them to V1. So if I apply this particular rule, I refresh, nothing. If I log in as Jason, I'll get red stars. If I log in as me, I'll still get no stars. So the video ended. We can actually go back to the slides, please, if we may. OK. So basically, the two things we just saw was one of them blue-green deployment, one of them being the specific user and routing the traffic according to the need. These are one of the many features Istio brings. So let's talk about Istio, what are the things Istio actually comes with and helps us with. First thing is traffic management, right? So Istio has ingress and egress control, so you can actually control who can talk to your cluster, and also you can actually control if your application should be able to call outside traffic as well. So if you have a service that's randomly calling this different API that you didn't approve of, you can at the policy level, you can stop that happening. You can use application knowledge based, for example, things like which browser this application is running on, what version of the app is this, who is this user, or is this user signed off experimental check. For my example, I was just checking username from the header and doing some checks on top. You can do similar things for your application. You can also inject fault on demand. So let's say you want to test how does your 10 microservice application does if you inject a fault at the 3rd level. What happens to the rest 7? You can also take out the retry logic and error handling logic out of your application code into the policy level. So in many cases, let's say some people will do 2 retries, and in your service application, it might be too slow because you're doing many retries on your application. You can take that out on the policy level, and without any changing of code, you can then get circuit breaking or retries from Istio. Telemetry, this is, I think, one of the biggest features of Istio. If your application has these headers set up, you can then collect these telemetries without changing your code at all, without having an instrumentation on the code level. You can collect things like who called the service, how long it took, if it failed, why it failed, who was the last person it talked to, and things like that. And you can use operators. So if you're using Prometheus already, it comes built into it. If you use services like Datadog, you can actually have an operator that passes the data directly into Datadog dashboard and collect metrics from there. Istio comes with built-in micro benchmarks. So if you can do some benchmark testing on your application for your microservices. And finally, this one is super crucial because, again, security is always an afterthought for us. So it can help with man-in-the-middle attack by simulating no security setup. You can enable MTLS between service-to-service communication, where without the proper certificates, even within your cluster, no one can talk to each other. So you can have a lot more security in that way. So final couple of thoughts. Again, I talked to you about a lot of great things, and they sound great. And you might be thinking, why aren't everybody using Istio? A couple of things to keep in mind is that there is no free lunch in this world, right? Istio gives you all these features, but it runs on the cluster, uses some CPU to be able to compute all these things. So you have to be very careful that if your application truly needs all these features. If it doesn't, Istio might not be the right solution for it, right? Just because the tool is cool doesn't mean everybody has to use it. It has to make sense for your application. So there are a couple of blog posts. I mean, I'm going to post these slide decks later, so you can click it. But if you want to take a picture and Google it yourselves, you can also do that. Yeah, so, and takeaways, right? Service Mesh, especially Istio that I talked about, extends Kubernetes capabilities. The things Kubernetes could already do, Istio makes it easier and makes it better for Kubernetes. And it can make some of the more difficult things that's in Kubernetes a little bit easier. Not completely solves it, but makes it a little bit easier. And finally, I'm basically standing between you and beautiful lunch over there, so thank you for staying and indulging my talk. And I'd like to hear more about your stories, your struggles, your comments, anything you have tried that's similar to this, or you build some custom tools to do similar things. I'd like to know more. If we can't chat today, please find me later, or find me at Twitter, at Moficodes, to be able to know. I'd like to hear more what we're trying to build. So thank you, and have a good lunch.